All right, welcome back into Python built-in functions. So Python, one of the things that people love about it is you can find the code for mostly anything you would ever want to do already written for you. So that comes in two flavors, things that are built in to Python and things that are added by other people and you can download as a package and run. And most of the functionality is already in there for common things that you want to do. So this lecture is going to be about some of the handy built-in functions that are available from just plain old vanilla Python without having to go get additional packages. We'll have additional lectures on some of the common packages that people use for GIS programming. So we're just going to go through these one by one. These are examples of things that are built in that make your life easier. This is not by any means a comprehensive list of everything that's built into Python. So some of these are really straightforward, others are not. So we'll go through these one by one, hopefully give you a basic understanding of what they do, how to use them. So first one is abs for absolute value. You can probably take a guess what this does. So this will take any floating point number. Floating point is fancy name for decimal, non-integer, including integers as well. It will actually work for as well, because the integer is a floating point number with 0 floating points, and give you the absolute value or the positive value of it. So if value is negative 8271, calling abs will turn this into the positive version. And if you were to print, it would print out the positive version. Very simple. Bool converts anything into a true or false. You could have done an if-else statement and set a variable equal to result. But why would you do that if there's a shorthand for it? So if the object X has a property called hasData, you can simply call it like this. So if hasData equals true, instead of setting a temporary variable equal to result and then doing something with it, you can do result.bool and pass in that. So that converts the equivalent of this into a Boolean, and that way you can save some space and impress your Python friends. Also not super complicated. Enumerate gets a little more complicated. So we've seen that you can go through lists by using the for in, but when you do that, you don't get the index of the value that you're at. So sometimes you would like to know, instead of just starting at the beginning of the list and going to the end of the list and looping through each of the values, you want to know the index of the thing that you are at. So the enumerate function takes in a list of some kind, tuple or square list, and returns the index and the value for each item in the list. So this is index 0, index 1, index 2, index 3. Remember, in computery, everything starts at 0. Most normal things anyway. So this is the 0 index, the 1 index, the 2 index, and the 3 index. So we're using this in a loop. Remember, for in. This is a little bit different syntax because we have two things over here and a function over here. This function returns those two things in that particular order because order is important. So this is just going to loop through pairs for each of these items in the list. So for the first one, it's going to be index 0 value, index 0 value June, index 1 value July, index 2 value August, index 3, value September. And then we can use each of those variables as we see fit. So we can print out the value, and then we can print out the index. So this would print out June, index 0. Notice that we're printing out the words space, @ space, index, colon, space. All right, so that's not in there by accident, that it shows this stuff. So this is handy because oftentimes you would like to know what index you're at for something as you're looping through, because you might want to exclude one of these at a particular index. And if you just loop through all the items in this list, you would have no way of knowing without a counter variable keeping track that this was 0, this was 1, this was 2, and this was 3. So enumerate, cool and useful. Eval, equally cool, but super dangerous. So eval allows you to write Python as words and run them. So this is handy if you need to execute some particular bit of Python code, but it is not actually in your code. So this is often run by bad people for executing things which are the values of receiving input from a user. So that is super dangerous because a user could write things that can harm your computer, harm your program, harm your company. So you need to use eval sparingly, especially when it comes directly from user input. But the fact that you can do this is cool, right? So here we have a variable named I being set to equal 4. Result is set to be the Python evaluated code that's inside of there. So I plus 1. So result equals I plus 1 at this point. Then when you print result equals 5. So you need to use this sparingly because you definitely don't want to do it by getting the code that goes into there from asking the user for input. Otherwise that user can run anything that's Python inside of your code. So cool that you can do it. I have never had a need to do it, but I'm sure they exist. Float converts anything, including a string, into a floating point number. So if it is number-ish, it will succeed. If it is not number-ish, like if it were the string hello world, then it would throw an exception at that point. So you can take user input in the form of numbers from files that you read or user input from the command line, convert it into a float by calling the float function, and then doing stuff with it. So print the value of 4.6 converted into a float plus 5 is going to print out 9.6. So this is data type conversion from string into float. We're not doing any error checking here. Error checking is a thing that we should do always, so we'll have a lecture on error checking. Has attribute, get attribute, and set attribute, and type are all things related to objects. So if you remember, objects have attributes associated with them. They can be class level attributes or they can be instance level attributes. Class level attributes are attributes that are the same across all instances of that class. So we have a class named vehicle here. You can have vehicle 1, vehicle 2, vehicle 3, vehicle 4. Class level variable says all of them get an attribute and its value is the same thing. Instance ones are where each instance of vehicle class, so vehicle 1, 2, 3, 4, all have their own unique values, potentially. So has attribute tells you if that particular instance that you're looking at contains an attribute with a name. So remember, Python allows you to add attributes to any object at any time. So if you do this outside of class definition and you're not sure if something has an attribute, then you can check before you start working with it. So here we have class vehicle. They all get because it's in the constructor, so it's going to get called every time. They all have a color attribute, and its value is red each time this constructor is called. So every time you create a new object of type vehicle, it's going to get a color attribute, and its value is going to be red. So we make my car, and then we do boolean equal to has color, or sorry, named has color, and its value is equal to does my car have an attribute named color? Boom, yes. So another boolean variable named has mpg. Does my car have a value or an attribute named mpg? Not as far as we can tell, so that one's going to return false. All right, so when we print that out and print that out, has color is going to be true because yes, it's in there. Has mpg is going to be false because not in this little code definition does it exist. So when you're adding attributes on the fly outside of class definition, or if you have inherited classes and you're not sure if that inherited class has something, because you might be working with the parent class instead of the inherited class because you're using interfaces and implementations and you only want to work the interface, blah, blah, blah. You may not know if that particular thing, object, instance that you're looking at has that attribute. You can test before you start trying to mess with it. Get attribute is very similar, where if it exists, then it's going to get it. So how does this one work? Right, we have the same thing. All vehicles in the constructor get color, make a car, and then color one, it allows you to get the value of the attribute color from that instance of my car. It's the exact same thing as doing this, my car dot color. Right, so they both operate the same way or result in the same outcome. Two different ways to do it. You might want to use one or the other for reasons, but primarily you'll be using this one because it's easier to understand. If you have an unknown set of attributes, you might want to use has attribute first and then get attribute. Like if you have a list of attributes that you read from a text file and you're checking to see if these particular objects you're working with have those attributes, then you don't know the name of it in advance because it's coming from a text file, so you can't write it in code. You have to write a loop that goes through and gets it from a file. All right, so this one is unknown name of attribute in advance would be an instance where you might want to do this. Input gets user input. All right, so we've seen this many times. This is console level input, so the Python window is going to be sitting there paused waiting for the user to type something. It gets assigned as a string into whatever variable name you use. Then you can use it as a string, you can convert it into an int, convert it into a float, whatever you want to do. You should not eval it, all right, because anything the user enters is going to run like Python that you wrote. So that could be delete C:/Windows. You would hope that that directory is protected with some kind of file directions or file permissions, but you never know. So you can get input from the user. You don't want to evaluate it, and you definitely want to check it for sanity before you start using it. Int, very similar to float, converts things into integers, which are any data type. If it is a numeric data type, it'll work and it'll do something. If it is not a numeric data type, it will fail. So interesting things about ints are that it truncates. All right, so if you're sometimes rounding, so if your original value is a decimal, integers by definition don't have decimals. So it's got to do something to convert from decimal value into integer value. And I believe what it does is it just chops. It's not rounding, it's chopping. Could be wrong about that. We'll double check and let you know. Let's write that down. So this is 12. 12. If int truncates or rounds. We'll double check, we'll update. Some languages do it one way, some languages do it another. Just gotta know what Python does and know what to expect. So this one becomes a 0 because the decimals or the decimal places get chopped off. This one becomes a 3 because the decimal places get chopped off. So very important thing to remember, because you may be working with latitudes, longitudes, and if you just convert them into integers, you're going to lose the decimals, and that will be problems. Cool. Is instance tells you what type your variable is. So you pass in your variable and the name of the class that you want to check, and it's going to return true or false depending on if that instance is a type of that class. So here we have my car and my truck. My car is a vehicle, my truck is a truck. Truck inherits from vehicle. Alright, so if we test out that my car is a vehicle, we get true. If we print out that my truck is vehicle, we get true as well. Because truck is an instance of truck. Sorry, my truck is an instance of truck, which is a subclass of vehicle. So this will return true if it is the child class or the parent class when you're doing this is instance of. Because everything that is an instance of truck is also an instance of vehicle. So if we do my car, is it an instance of truck? My car is a vehicle. At this level, we don't know anything about subclasses. So child classes know about their parent classes. Parent classes don't necessarily know about their child classes. So this would return false, because my car is a vehicle, my car is not a truck. You can know specifically if something is a subclass. So if we have two classes, one is a truck, which inherits from vehicle, one is a vehicle, you can determine if is subclass, first class is subclass of second class, and that will return true. So this is important to know as you are working with classes and you have very complicated structure and you're not sure what you're dealing with at this particular time. You can tell if your particular variable is an instance of a particular class, and you can tell if one class is a subclass of another class. So iter stands for turn something into an iterator. Iterators are things you can loop through. Lists, dictionaries, tuples, all that good stuff. Not every class supports being converted into an iterator. Inside of the class definition, you have to override the dunderscore iter and say how this class is supposed to be converted into an iterator. If that overridden method is not in your class, then this won't work. We'll see special class functions in a later lecture. But if something supports being converted into an iterator, it allows you to do that and then loop through each of the items in the iteration, or in the list of things resulting from, in this case, the readline function of file. So the way it works is this is your thing that gets converted into an iterator. This is your stop condition. So this is saying read all the lines of the file until you get to a blank line and then end. So you don't have to have this second parameter here. If you do, it's going to be dependent upon how the dunderscore iter function was overridden in the FP or the file class. So we have some strange syntax here as well, where we have with open this thing as file pointer, FP, do some stuff, do more stuff. So this is a lot of shorthanding going on in here. So this is a different way of saying open a file, get me all the lines, loop through them, and then do something with the line. So as with all programming, there's 25 different ways you could do the same thing. So this is different Python syntax for defining a variable named fp and setting it equal to the result of opening a text file. This has to do with variable closure and all that kind of good stuff, and automatic closing of the file. We may or may not have a special lecture on this just because it's some strange syntax, and you're going to see it all over the place. Probably will. So basically, create a new variable named fp, set it equal to the result of opening a file, and then create an iterator from fp.readline over and over and over and over again until you get to a blank line, and then for each of those set a variable named line equal to the contents of that line, and then do something inside, which is process that line, which is a function that doesn't exist right here. Assume it does somewhere else. So this is all shorthand. There's longer hand ways of doing this that we've seen in prior lectures about opening and dealing with files. This is Python programmers being fancy and shorthanding things to make less code. This little part up here is for automatic closure of variables in terms of scope, as well as potentially automatic closure of file. So iterator, semi-complicated-ish. You'll probably see a lot of examples of this online, so now you know what it means. Convert something that is iterable, and then use that to make something that can be looped through, and then loop through it. Len means length, so return to me the length of something. So if you give it a list, it's going to give you how many items are in the list. If you give it a tuple, it's going to give you how many items are in the tuple. If you give it a string, it's going to give you how many characters are in the string. Returns an int, because there's not going to have a decimal length of any one of these. Important to know for avoiding infinite loops and reading files and reading database tables that are returned to you, data tables, so you know how many things there are in your list as you're looping through it or as you're processing it. Max gives you the biggest one, takes some number of arguments. If you give it two things, it's going to give you the biggest between the two of them. If you give it one thing, it's going to give you the biggest in that set of things. So between 6 and 8, maximum is 8. And then if you give it a list, maximum in here is 5. All right, so this is depending on how you think about it, an example of polymorphism, where you have two functions that are implemented different ways given different parameters, or method overloading, function overloading I should say, because this is not related to an object. So there's two functions with the same name. If you give it two parameters, it does one thing. If you give one parameter, it does another thing. Based on the data types of the parameters that you give it, it's going to do different things. So if these were both lists, it would get the maximum of the first list, maximum of the second list, compare and give you the maximum of both of the lists. If you give it one list, it's going to give you a maximum of that single list. Min, same thing, find the minimum. Next is a little interesting. It moves you through an iterator. So we talked a little bit about iterator a second ago. So when you convert something into an iterator by calling iter, you then have the ability to call next on it and move one index forward. So we have a list, 1, 3, 4, 5, 6, 7. Convert that into something that is iterable, meaning an iterator. And then once we have an iterator, we can call next on an iterator to move our way through. So this is useful in certain instances, overkill in others. For streams, when you're handed data piece by piece by piece by piece that keep filling up an iterator, it is sometimes common for you to have to call next to get the next item in the list until next equals null. So you might do a loop where it's a while loop until next is null, and then you just keep running. So as your stream from a file or TCP/IP connection is handing you stuff, just keep running while next keeps operating, and then when there's no more, next becomes null, and then you exit your while loop in that case. So kind of weird, only makes sense in certain instances. You'll know if you need it. Open, we've seen a lot. Tries to open any kind of file located at the location of the first parameter with the permissions read, write, append, r+, w+, a+, and gives you back a variable who is the file, which is an object that you can then do stuff to, like read line, read lines, read all, read certain amount of bytes. POW is how you do exponents. So here we have our base is x to the exponent y. So 2 to the power 4 is 2 times 2 times 2 times 2. So 2 times 2 is 4. 2 times 2 to the power 3 is 2 times 2 times 2. That is 8. And then 8 times 2 is 16. So this is how you do exponents in Python. Print is going to write stuff to the console. Range does some interesting things for us. It allows us to generate a range of things, and it takes a couple different sets of parameters: 1 parameter, 2 parameters, or 3 parameters. So when it's a 1 parameter case, it creates for you a list starting from 0, counting up to that thing, which can then be converted into the list, right? So if you just print a list, you're going to get the starting value and the length. If you print the list parameter or list function of a range, it's going to actually print out the real data inside of it. Notice it goes from 0 to 9 because there's 10 items. You always start counting from 0. But the more interesting case is when you have 3 parameters. So where do you want to start at? How many do you want to go? And what do you want to count by? Right, so we're saying we would like a list between 1 and 10, but don't include 10. This is an important thing about Python, like splices and ranges, is that the last number is not included in the range. So from 1 to 10 actually means 1 to 9, and count by 2. So 1, 3, 5, 7, 9. So the maximum value is going to be 10 here, but if we were to add a 10, that's not something that we count by. So the next one would be 11, so that's why there's no 10 here. So it would have gone from 0 to 9. Oh, sorry. Indices long. So there's 10 items here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 things long, counting by 2 each time. So this is how you could generate a list of numbers for yourself for a purpose that are starting at 1, going 10 places, and counting by 2. So if you have 10 things you need to do, starting at 0, this is a way you can loop through 10 things. So range generates for you a list of numbers that is useful for things in the future. Reversed flips the direction of a list or something that can be iterated, an iterator. So your original list is 1, 3, 4, 5, 6, 7. When you set a new variable equal to reversing that thing, then your new values are starting from 7, 6, 5, 4, 3, 1. So that will flip the direction of your list. Here we're using next because next works on iterators. So that'll print out the first thing, second thing, third thing in reversed order because this value is now the reverse of that one. Round allows you to round a number to however many decimal places you would like. So you got pi here, 3.1415. That's as much as I can ever remember. And it rounds the number to however many decimal places you like. Set attra is related to objects again. So it's equivalent to doing instance, variable name, dot, property. You can do it in more complicated way if you wish, or you can do it in dot notation, simpler way. Again, the reason you might want to do this is you might have unknown objects that are being given to you with unknown attributes associated with them. So you might have to go to a repository, get the attributes that are supposed to be part of this object along with their value, and then set their values. So there are use cases why you would want this. Has attr, get attr, and set attr. So slice gives you small sections of a list. It as well has crazy notation that you would not expect. So it's the starting index and then the ending index minus 1. So it's got ridiculous notation that is like real crazy. So I have it up here in my screen. Oh no, where is it? It's got ridiculous notation that you can use. Some of them start from the back or start from the end and work backwards. Some of them start from the front and work forwards. Some are how many you want and what combination. So it is a sort of complicated thing for simple idea. Slice allows you to just say, I want the 0, 1, 2, third, fourth, and fifth object out of some gigantic list. So the result of calling the slice function gives you sections of this. So you can make a slice object and say, where do you want to start? Where do you want it to end? Not inclusive. So the fourth thing counting is not included. So you can pass pass X, the slice object, in an array notation, or you can just pass in the number that you want. All right, so why is this complicated as hell? Because you're like, all right, start at the first one, go 4. So start at the first one. Are we talking about the 0 index or the 1 index? Shit, I don't remember. So it would be the 1 index where this is 0 and 1. You're like, okay, so I want 3 of them. So I want 1, 2, 3, but you have to write 4 because the ending point of the slice, in this case, 32 onward, is not included. So slice notation will mess you up. You just got to get familiar with it. When you're looking at other people's code, it's not going to make any sense. So you're going to have to think about it and go back to the documentation to see what the different notations mean. It's a mess. We may have a special lecture just on that. But basically, slice gives you chunk of existing list, tuple, or dictionary, or something iterable. It's used all the freaking time, and the notation will be insanity. So let's look at some of these. High-low, negative stride, cool. So we got slice, 0, blah, 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 blah. So ugly, ugly, ugly. But is very useful. So the alternative to this is loop through this whole list until you get the number that you want, and then keep going until you get the collection you want, and then stop. So slice is actually extremely powerful in that you can get chunks with simple syntax-ish. Syntax can be difficult. Sorted, take a guess what it's going to do. Sorts a thing. So if you start with a series of characters in a row, also known as words, as a variable, and then you sort that, it's going to rearrange all the items in here in alphabetical order. So there's also reverse sort as well. So sort can take one parameter, which is the thing you want to sort, or one parameter plus a second one, which is to reverse or not to reverse. And then when you print it out, it's a sorted copy of your original. Right? So first thing in a list of alphabet is space, because space comes before any of the characters, and then all the individual letters now in sorted order. The reverse sort is the reverse of that. So this is pretty handy that you can sort things just by calling sort, because there's like actual computer science about how to sort things, because there's lots of different ways. There's breadth first search, depth first search, bubble sort, gazillion different types of sorting algorithms in computer science. You would have to check the documentation of the time complexity of sorting with this particular function, which is built in with Python. But if this one is not fast enough for you, go to Google, type in Python fast sort, and you'll find Stack Overflow examples of gazillion different ways of sorting from different packages. So this will sort for you, and will have an amount of time that it takes, and that it will be in the documentation which specific sorting algorithm it does. Str turns things into strings. So if you have a variable named x, its value is 43, and you have a new variable set to be the result of calling the function string on x, you're going to get ugly ass output. So as we were talking before, you can override things inside of class definitions. So one was dunderscore iter, another is dunderscore len, another is dunderscore str or string. So if you would like your objects, when they are turned into a string, to say something that is not this class space int, then you have to override dunderscore str dunderscore in your class definition and make it print out what you want it to print out. So converting most things into strings does not give you useful output, because for whatever reason this was not overridden. Integer toString was not overridden inside of the Python integer class. Some take a guess what it's going to do. It's going to add them all up, the things in your list, and then return the value. The alternative is for you to write a loop that goes through and adds them all together. Don't do that. You have built-in function that does that for you. Imagine if you were adding up, like if you wanted to call sum on a list of months. What's that going to do? So in that case, string, the class, would have to have overridden the sum function. So basically, I hope you're seeing that if you want your particular stuff to do special things when called sum, when called string, when called length, when called equals, you just have to build that into your class, and then people can use regular Python functions on it, and it will do sensible things. So if this was HELLOWORLD, what's going to happen when you sum that up? Only way to know is find out. I don't think it's going to do something meaningful. Tuple is basically no name function, right? And it builds a tuple for you. So notice that this is name of thing, and every other base function, open parentheses, thing, close parentheses. So tuple is blank name, open parentheses, list of parameters going in, close parentheses. So this returns you back a tuple objects. List is the same, except you use square brackets, and boom, you got list. Alright, and finally, type prints out the class name of the thing that is your variable. So if you make an x variable name, set it equal to an int, and then you make a stringy variable name and set it equal to the value of turning x into a string. And then you print out the type of x, it's going to print out int, and if you print out the type of stringy, it's going to print out str. So when used in combination, type, set attribute, is subclass, is instance, all these class related things allow you to do very complex programming where you don't necessarily know what the data types are that you're working with all the time. So this, depending on the pattern of programming you use, this might happen all the time. So you can probably imagine inside of ArcGIS like a geodatabase, a CSV that's turned into a data table after doing the import, reading a shapefile. There's not, 3 different versions of how those things are handled. They're all converted into feature class, right? So when Esri's software is reading in a bunch of different formats, it doesn't necessarily need to know or want to know what your specific format is. It just needs to know that there's things that happen to feature classes. So they may have used one particular type of programming called abstract factory pattern, where you have producers of objects depending on what type of data is given to it. So there are actual instances where you don't know what the original data type is, but it's helpful to be able to know that if you need to. So if you needed for whatever reason to know that this feature class is actually based on a shapefile, or this feature class is based on a geodatabase, or this feature class is based on a CSV that we read in as an event in what happens when you do add XY data inside of ArcMap, you can know that because there might be special things or special attributes associated with those different actual physical data types, and there might be special methods that you can do for each one of those. So all this weird stuff about what class am I, what attributes do I have, can I get or set attributes is actually useful once you start getting into more complex programming where you have a lot of different types of objects that you need to deal with. So this was a super whirlwind run through of a lot of the built-in functions that Python has. You might have seen there's like a lot of math ones, there's a lot of data type ones to convert things from data types to another. There's a lot of things with lists of stuff. Turn it into a list of stuff, iterate through the list of stuff, move to the next item in the list of stuff. There's random stuff like eval, where you can write Python to execute other Python, kind of cool. And then there's generally class-based stuff. So there's like not a whole lot of mystery here. These are all things that are built into Python that you don't have to import additional packages to do. This is all just standard out-of-the-box Python stuff. If you want your objects to be able to do some of these things, like I want string to work when people call it on my function, or I want iter to work when people call it, I want string to work when people call it on my objects, and I want iter to work when people call it on my objects. Totally doable. You just have to override the _ name of thing, _ in your class. So that's some built-in functions in a nutshell. Enjoy.